Hey everyone, welcome back. Today's topic of discussion is quartile deviation, which is one of the measures of dispersion. We have already discussed what range is and in which situations range is used in the previous class, which I have provided an iCard here. Just click on it to know what range is. Let us now learn about quartile deviation. The name itself tells that this measure can be found out using the quartiles. But what are quartiles? We generally have two quartiles, Q1 and Q3. Q1 separates the least 25% of the data from the remaining data set, and similarly Q3 separates the highest 25% of the data from the remaining data set. That is, Q3 separates highest 25% of data. Suppose my data is spread like this: Q1, Q2, Q3. So Q1 separates the first 25% from the remaining data set, and Q3 separates the highest 25% of the remaining data set. Right? Using these Q1 and Q3 of the given data, we find out the quartile deviation. But why quartile deviation? First thing, the quartile deviation is less influenced by extreme values. In range, the data is influenced by the least and the highest values. Those are the extreme values. So, quartile deviation overcomes that demerit. The second one is quartile deviation formula is easy to calculate. The third one is it helps to identify the pattern of the data more clearly and about the distribution, and also tells about the distribution and shape compared to that of range. The formula for quartile deviation is half of Q3 minus Q1, where Q3 is the third quartile which separates the uppermost 25% of the data from the rest of the data. Similarly, Q1 is the first quartile which separates the lowest 25% of the data from the rest of the data. Let us consider this as my example for individual series. My data is totally this. I have been given values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 values are there. So what I'll do is, first of all, I'll arrange this data into an increasing order, that is placed from 2 to 14. I can find the mid value, which is median, to be 6. This is Q2. The middlemost value, that is the sixth value here, is 6, which is Q2. Now, I have the lower part of 5 values and upper part of 5 values. The lower part of 5 values again will have a middle value, which is nothing but Q1. The lower part is 2, 2, 3, 4, 5, and the middlemost value of this will be 3, which is Q1. Similarly, in the upper part also I have 5 values. The middlemost value will be 9, which is nothing but Q3. So the first quartile value is 3 and the third quartile value is 9. We have the formula quartile deviation is equal to half of Q3 minus Q1. On substitution, I get half of 6, which is nothing but 3. This is my absolute measure of dispersion. Quartile deviation is the absolute measure of dispersion. Whereas to find out the relative measure of dispersion with respect to quartile deviation, I have the formula Q3 minus Q1 divided by Q3 plus Q1, which is 9 minus 3 by 9 plus 3, that is 6 by 12, which gives me 0.5. The difference between absolute and relative measures of dispersion is that absolute measure is the exact value, whereas relative measure is in comparison with all the data that is available in the data set, which gives us more efficient and precise value of dispersion. Let us consider this example for discrete series. We have taken heights of 9 students and the frequency of each height. Totally 8 students are of height 153, 2 students are of height 155, so on. 4 students are of height 169. We need to find out the quartile deviation for this data. First, we find out the cumulative frequency of all the frequencies. Total frequencies is 39. We know how to find the cumulative frequencies. First one will be same, 8, 8 plus 2, 10, 10 plus 4, 14, 14 plus 6, 20, so on. Now, here in discrete distribution, we know that capital N is equal to sigma Fi. Sigma Fi is nothing but 39. Small n is equal to Number of values here is 9. So capital N is equal to 39. Q1 is equal to, the formula for Q1 here will be N plus 1 by 4th item. Capital N is 39. So 39 plus 1 by 4th item will be 40 by 4, that is 10th item of the given data. 10th item you need to see in this column, cumulative frequency column. The value 10, the value equal to or just greater than 10 will be our required value. The value which is 10, 10th item. So corresponding x value is required, which is nothing but 155. 155 will be our Q1. Similarly, for Q3, we have formula 3 into n plus 1 by 4th item. That is 3 into 40 by 4th item, which is nothing but 30th item. We need to see cumulative frequency column. The value just greater than 30 is required. This is the value which is just greater than 30. And the value of x corresponding to 34 here is 165. So 165 will be our Q3. Substituting in the formula, Q is equal to half of Q3 minus Q1, which is half of 165 minus 155, which gives us value 5. 5 is the quartile deviation, which is the absolute measure of dispersion. To find out the relative measure of dispersion with respect to quartile deviation, we have the formula Q3 minus Q1 by Q3 plus Q1, which gives 10 by 320, which is equal to 0.03125. Now let us see an example for continuous series to calculate quartile deviation. Let us consider this as an example for continuous series. We are totally given 7 class intervals, their respective frequencies. We need to find out the quartile deviation. First, we'll initially find the cumulative frequencies of the given data. 6, 6 plus 5, 11, 11 plus 8, 19, so on. And we find the mid values of the given class intervals as 0 to 10, 0 plus 10 by 2, 5, 10 to 20, 10 plus 20 by 2, 15, so on. Now we need to observe that the formula for the first quartile will be L plus H by F into N by 4 minus C. N is the total of the given frequencies, that is 50 as we know, and Q3 is equal to L plus H by F into 3N by 4 minus C. Now N by 4 will be 12.75, 3N by 4 will be 37.25. See the value N by 4. N by 4 is 12.75. Observe the column cumulative frequencies. The value just greater than 12.75 is 19. So this will be our required Q1 class. 20 will be L. H value is 30 minus 20 and F is our 8. C will be the value preceding 19. That is 11. Substitute in the formula to get 22.19. Similarly, for Q3, we first calculate 3N by 4. That is 3 into 50 by 4, which gives us 37.25. Come to the column of QF. Find the value which is just greater than 37.25, which is 41. 41 will decide our Q3 class. The class interval corresponding to 41 is 40 to 50. So L will be the lower limit of 40 to 50, which is 40. The frequency corresponding to 40 to 50 is 7. So that is F. And the value preceding 41 is 34. Substitute these values. 40 plus 10 by 7 into 37.25 minus 34, which gives 44.64. Substitute Q1 and Q3 values in quartile deviation to give the value 11.225, which is the absolute measure of dispersion with respect to quartile deviation. Now, the relative measure of dispersion with respect to quartile deviation is coefficient of quartile deviation. The formula is Q3 minus Q1 by Q3 plus Q1. Substituting the values, we have 0.16796. Now, quartile deviation, as we know, concentrates only the 50% of the data, more precisely in the middle part of the data, middle 50% of the data. It ignores the rest of the 50% of the data and also the outliers of the data, that is the extreme highest value and the extreme lowest value. So this also gives an incomplete information about the data. This is the reason why we go for the other measures of dispersions like mean deviation and standard deviation. Quartile deviations also get affected with sampling fluctuations and cannot respond properly for further algebraic treatment. In the next class, we'll discuss about the mean deviation. Please stay connected and thanks for watching.